afternoon. Welcome to the CWPCA Virtual Safety Group webinar on Equipment Guarding Safety Standard. This is the fifth in one of our series of new standards as requested by our members. The agenda for today is a brief introduction of the Virtual Safety Group, responsibility of your legal reminders for all employers, a review of what a safe work procedure is, talk a little bit about machinery and equipment guarding, what the requirements there are, and where to find copies of this information on the CWPCA website. So what you see there are two pictures. One is some guarding around a piece of machinery, and one is signage, both of which will be referenced later on in the presentation. So we start our procedures off with a disclaimer. So this is a presentation designed to assist our members in training their workers, but it is not workplace specific, okay, nor does it treat the topic exhaustively. What it is an introduction to workers. We would call this perhaps orientation training, and the guidance to any employer is that he should develop, deliver, and document the training for all workplace-specific equipment. So if you have a bandsaw, a stacker, destacker, or shredding device on site, you need specific guarding reviews and training specific to that piece of machinery. Okay, so we started training off by talking a little bit about competency and who a competent person is. So under an Occupational Health and Safety Act in any of the provinces in Canada, it's somebody who has is qualified through knowledge, training, or experience to deliver the training. They must be aware of the health and safety hazards that apply to the workplace, and they must have some knowledge of the regulations. And in Canada, the regulations are specific to the Provincial Occupational Health and Safety Acts, and we specify the Ontario Act in this presentation. It requires some knowledge of the electrical code, and specifically guarding is governed in Ontario under the CSA Z 43204 standard. We also cite standards relating to packaging equipment. So the key point is this is probably one of the most safety sensitive types of training that you deliver. In my experience, you want somebody who really knows what they're doing, and I typically have a maintenance person beside me when we're doing this type of training. So just a review of the training tools that we provide our members. So a safety standard or safe work practice is a written method that outlines how the task is to be performed. In general, this is what is provided to people. In my experience, though, the training is what is lacking. So we provide a training presentation that can be customized to your particular location. And in our workforces, what I found best to do training with is a visual representation of what's going on in the workplace. So I use plenty of pictures because they help make it real for the people being trained. And thirdly, we provide examples of training records. And I can't emphasize this more than the simple fact that when the ministry comes on site, they'll ask for two things in case of any incident, and that is records of your training and records of what they were trained on to test for accuracy. So please make sure that you have your training records attached to the following presentation. Okay, so brief introduction to the hazards associated with working around machines. So in every one of our workplaces, machines, tools, and equipment are what we work with every day. We couldn't work without them. However, human flesh interacting with these type of machines have the potential to create very serious injuries if they're not used or maintained properly. So a review of the particular types of hazards are contact with moving parts. That could be roller conveyor, drive chain, stackers, slug feeds. It could be bandsaw components. It could be table flippers, scissor lifts, anything that has moving parts that represents a safety hazard. But also it's the contact with the energy that supports those moving parts. So that is typically electricity, could be heat, could be fire, coal, could be hydraulic, could be gravity. So those are the other particular safety hazards. But there's also health hazards, which are contact with hazardous chemicals or biological hazards. An example of that would be mold on lumber. That is particularly hazardous, especially in an impaired health condition. Also, it's contact with harmful noise or radiation or vibration. And lastly of all, there's exposure to ergonomic or MSD hazards. You'll be able to recognize machine and equipment hazards, the guarding requirements and standards that are applicable, and machine risk assessments after following this presentation. So, a little bit of a description about what the definitions are in equipment standards, or equipment guarding standards. So first is what we call an end-running NIP hazard. So that's where a drive chain is going over a sprocket typically, and there's a pinch point that exists between a belt, pulley, chain, or sprocket. And you see an example. So what we're talking about is you get your finger caught between that sprocket and the drive chain, that's a NIP hazard. There's rotational. So there's the where you have a belt or a saw or a gearing or a chain. That's the other issue that creates potential hazards on a piece of machinery. We talk about reciprocating, which is the up and down motion of a jigsaw or drill press. Transverse motion is the straightforward movement of a conveyor or a belt sander or bandsaw. Fixed barrier guard is something that can be that is attached to a machine and that can only be removed with a tool, for example, a screwdriver, a hex wrench, or a wrench of some part. Interlocking guards, those are the type of guards where you have typically a fence and a door which, when opened, de-energizes or pulls the electrical power from the machine. An adjustable or self-adjusting guard is the example of the skill saw, where the cover moves while you're pushing the lumber through the blade. So that's an example of an adjustable guard. And a suitable guard material. The key point here is that the type of material used wouldn't be plastic sheeting, it wouldn't be typically wood, it would be metal screening, wire cloth, heavy duty plastic that gives you some level of visibility, which can withstand use over time. So, what is a hazard? It's an act or condition that exposes a person to a harmful chemical or physical force, causes adverse, acute, immediate, and recognizable impact on people, the environment, and environment. It violates government laws. And these two photos are examples of a hazard. One is a unprotected drive chain, and another is a table saw that's not guarded properly. So two examples of a hazard. In terms of additional risks, what is a risk? Okay, so when we're talking about equipment risk or risk around equipment, it's the combination of the likelihood of the accident occurring and how severe the injury could be. In terms of probability of occurrence, so these are terms that are used around equipment guarding. It's the length of exposure, significance of the hazard or the potential severity. And severity means, the difference between a sliver and an amputation. That's a degree of severity. Poorly managed or unmanaged hazards are all conditions that affect probability, and once again, it affects government laws. So how to determine if machinery guarding is required? workers should ask these questions. Can I touch it? Does it move? Can it hurt me? If the answer is yes to any of these questions, then a guard is required. And the terminology that we use when we're determining guarding is around, under, through, or over. If anybody can reach around, under, through, over your control to access a moving part, then it's not adequately guarded. This is something to remember when you're doing, guarding around moving parts. Here's an example of somebody spent a lot of money to put a guard over the drive chain moving some roller conveyor. And inadvertently, they've left an opening. And if anybody got their finger into that little opening when it was in an engaged position, obviously there's a severe potential for an amputation. So that's the type of thing that you're looking for when you're doing a guarding review on a piece of equipment. To determine if machinery guarding is required, you want to look at the potential health and safety risks involved when contacting those moving parts. So here we see an example of a belt conveyor with an open gap where if you get your thumb caught into that, once again, the drive chain that moves that belt could severely damage your finger, or your thumb in this case. So the potential injuries include cuts, bruises, crushes, amputation, and possibly death. Other types of hazards are noise and vibration, contact with electricity, heat, and awkward posture, which contributes to ergonomic illnesses or musculoskeletal diseases. So how do you determine if guarding is required? In most cases, the primary method is to do a risk assessment survey, and this can be done by competent personnel on your health and safety committee, but more likely it's done with a certified health and safety engineer. And the way they do that is they look at the potential, or they look at the piece of machinery, what the potential injury, the worst that could happen, and they classify it, and then they estimate or they rank the type of injury that could occur. And that gives you a priority rating on how serious a potential problem is and what needs to be dealt with on a priority basis. So these once again can be done within the context of your health and safety committee, but you need some kind of certification or orientation. Okay, so the type of activities that cause typical injuries. Okay, so type of machine activities that you want to pay attention to are any time it's starting or stopping, loading or unloading machines, setup and adjustment, cleaning and maintenance, troubleshooting and repair, and exposure to personnel nearby. And the example that we use here is you've got a guard on a bench grinder and it's been flipped up. It's in a start mode. What you want to be very careful about is that the training of your employees makes them understand that before that machine is turned on, that the guard is over the grinding disc. And the sensitivity to that is that if there was any part of that grinding disc that collapsed or broke apart at that high speed of rotation, it could easily puncture some skin, take out a tooth, or damage an eye. So those are the type of activities that you would want to focus on when you're doing your training. In terms of guarding procedures, these are the kind of steps that you should be following when you're doing your guarding of equipment. First of all, ensure that new equipment is installed and set up according to the manufacturer's instructions. Before operating any equipment, review the owner's manual and understand the specific safety instructions before operating. All workers should be trained on specific machinery operating instructions and have that documented. When changing the design of a piece of equipment, which includes retrofitting your own guard, get the equipment inspected by an approved engineer before use. Because once that's changed, you assume full liability for those modifications. Prevent access to all moving parts by ensuring that a suitable guard is in place. And a suitable guard must protect workers from all in-running nip points. Guards must protect the person from lumber movement, including waste stock, and not just the moving machinery parts. A good example of this in the pallet repair business are dismantlers, right? So we have a dismantler, either a bandsaw or something that works off rotating discs. While that is cutting either a stringer or cutting a board out, there's a potential for that lumber to pop free and smack the operator in the face. So any guarding just doesn't protect the employee from accessing parts of the machinery, but it protects them from pieces of lumber flying up and hitting them in the face or other part of their body. It also requires emergency stops on the machine that must be seen and are easily accessible. Emergency stops, or e-stops, must include, will include either the red button that you press, typically on a piece of machinery, or what you see as a pull cord that runs the perimeter of a line. To ensure the startup button is protected with a collar above the machine so that it prevents it from accidental startup. So this is a standard that we see on most pieces of operating equipment. You want to keep long hair suitably confined, either with a net or a hat. Anytime you're getting close to a shaft, a spindle, a gear, or a belt, or any other source of potential entanglement. You want to make sure that guards are no more than 5 millimeters away from a belt or a pulley so that you can't get any parts of your body or clothing caught in it. In the event that a guard is removed for the purpose of maintenance, all workers must be trained to immediately lock that piece of equipment out and tag it to inform others not to use that piece of equipment. In the event that an employee identifies a piece of equipment or machinery that's not properly guarded, they need to be suitably instructed on how to notify their supervisor, how to apply lockout procedures until the guard is properly installed. In terms of what you shouldn't be doing around the machinery is that you shouldn't be wearing any jewelry, clothing, or hair that is loose or dangling near a rotating shaft, a spindle, gear, or any other source of entanglement. In my own personal experience, mandating a no jewelry policy in a workplace is difficult, but so is having your ring finger caught in a drive belt, because the damage to that finger is just unbelievably severe. So I'm a strong believer in having a no jewelry policy in the plant. Do not make any adjustments or clean a machine while it's running in order to prevent contact with those moving parts. And this is something that really has to be enforced with your maintenance people, because they seem to have a tendency to want to test or adjust machines while they're operating, which can present some real risk to your maintenance people. Also, you want to make sure that machines are not left running on their own unless the machine is designed for this purpose. And a good example of this is that around, for example, nail guns. Once the nail gun is left not being used at break time or lunch, it's a good idea to disconnect the nail gun to make sure there's no risk of accidental firing. And the last one, but not the least, never disable a guard on a device. And I'll give you just one or two simple illustrations. Wiring back the cover on a table saw so that you can or a bandsaw or any other type of device so that you can get production faster is totally the wrong approach. And in my experience, disabling a guard is ground for discipline. And here you have a picture of somebody that's got a potential for a very serious accident by getting too close to that belt with some loose hair. Okay, so these are some tips that can be applied to your workers while they're working around machines. So, you know, everybody should be wearing their PPE, including face glasses or a face shield. You want to be wearing suitable hearing protection because in most of our plants, the decibel level exceeds the threshold set by the regulatory agencies. So you want to protect your hearing while you're inside our plants. Use gloves to protect your hands from splinters. However, you want to be very careful about using gloves around rotating parts because those rotating machine parts can catch the glove and draw your hand into it. Wear your steel-toed equipment to prevent your feet from any falling lumber. Use a dust mask or a respirator to filter out any wood dust inside the plants. Make sure you're watching for nails when you're cutting through lumber. Ensure that your hands are kept free of the cutting path. Use a push stick if necessary to ensure that your hands are kept well away from a blade of an operating saw. And keep your dust levels down through the use of suitable ventilation system, and make sure that wood dust is cleaned from your walls, poles, building supports, and machinery on a regular basis to prevent buildup and the risk of fire or explosion. We want to talk a little bit about what we call the hierarchy of control. So you see a little diagram over there, and basically the hierarchy of control says, if you read from the bottom to the top, the best way of eliminating a hazard is prevent the hazard from occurring in the first place. So, for example, if you find you have a machine that's generating a significant amount of dust inside your plant, and trying to prevent that from happening would be, you know, the best way to do it is get that machine out of there if at all possible. If you can't get the machine out of the plant, then change the process or substitute it for something that's non-hazardous, or potentially purchase a device that doesn't pumping all that dust into your workplace and creating that hazard. So that's what we call a level 1, or eliminate the hazard from the workplace. The second stage of the safety hierarchy is to put some guards in, or some walls or enclosures or ventilation. So in this particular case of a machine that was generating a lot of dust, what you do is put a ventilation cap over it with some suction or vacuum pressure to pull the dust away from the machine and bag it or put it into an enclosure. The next level is administrative control, which is, and this follows a level of least, what's the right word for it, least effective. So that would be the installation of administrative controls or warning. So this would be, if there's a machine generating a lot of dust, you'd have people rotating instead of staying at that workstation all the time. You'd create awareness. You'd put up, some instructions that says you can work at this job for no more than 3 hours a day. After, you have to move to another position because of the exposure to the dust. That's what we call an administrative control. And then the least effective would be signage that says, be careful of dust, or some kind of communication or training about that. So what you see is it moves from most effective to least effective. The best way to eliminate the hazard is get it out of the workplace. The least effective method of eliminating a hazard is training and signage. Okay, so that's just an introduction to what we call the safety or control hierarchy. In terms of safety guarding, there's some fundamentals that we talk about, which is to prevent contact with either the body or the clothing. Make sure it's secure, it can't be removed. Protect from falling objects. So this is a particular concern around stackers and destackers, where the real risk is that the stack of pallets would fall out of a stacker onto a worker. Create no new hazards when you install guarding. So, the key thought here is that, you're cutting metal to fit over a piece of operating equipment. You want to make sure that those sharp edges or unfinished surfaces don't create a hazard for the worker as well. Whatever guarding you install shouldn't prevent the worker from doing the job quickly and comfortably. And the last consideration is that what you want is to be able to ensure that whatever guarding you put in place, the machine could still be safely lubricated or maintained. So if we look at this particular piece of equipment that's typical to any plant in Canada, we have a compressor. And what's been done to guard it is you have a large flywheel coming off the cylinder head, and that's a moving part, and you see that red fixed barrier installed around the large flywheel to prevent access to it. So that's an example of how you'd properly guard an air compressor. Here's another typical example that you would see in a plant. This is a plant that operates what they call a vacuum lift, which is involved in sorting pallets. And here's an example of where the original equipment manufacturer installed some roller devices to allow the bar to move up and down the rail. But if that ever gave way, it would injure the worker, right? So if the rollers failed or became separated, that would come down on the worker's head or the back. So the guarding solution is to install a steel cable wire over the rail that would prevent it from falling on the worker below. So there's an example of a guarding device on a vacuum lift. The next example of a guard on a radial arm saw, which is once again something that is quite prevalent in any of our people making export wood packaging, is that on the first picture what you see is a unguarded lower blade. So it's wide open, and this exposes the worker to all kinds of potential risk of that as that saw cuts through whatever material you're feeding through it. The guarding solution is to encase the upper half of the saw from the blade down to the end of the arbor with a fixed guard, and then guard the lower half of the self-adjusting, or what we call a floating guard, so it moves through the wood as you cut through it. Make sure the saw has a return device so it doesn't sit in a forward position, and put a stop on it so it can't creep beyond a certain distance. Those are all examples of how you would guard a table saw, and once again, this is something that we would see in virtually any of our of the facilities that are making export wood packaging. Here's another example. The bandsaw dismantler is something that is used quite a bit in our industry, especially in the companies that are recycling white wood. And here's an example of an old table saw where it exposes the worker to all kinds of hazards, both from the blades, from the doors where the equipment is moving, to the saw gearing, which is just a complete hazard to the individual involved. And the guarding solution, as you see in front of you, is to put barriers that prevent access to the worker, both to the saw blades and to the devices that move the blades forward. The last guarding example is, well, something we've talked about is around the roller conveyor, and you see the roller conveyor that's been properly guarded in the lower picture. So in terms of lockout tagout, something to remember that safeguarding is the first line of defense for ensuring that the worker safety is operating powered equipment. Lockout protects the worker when the machinery is shut down for repairs. So anytime a worker removes or bypasses machine guards or any other safety device, it will result in exposure to a hazard. It places parts of the body in contact with point of operation of the machine. And it places parts of their body in the danger zone when operating this machine and operating cycle. Example of emergency stop devices. So we put two of them. We talked about this a little bit earlier, but this is an example of what an emergency stop is. So for your workers in the classroom, the E-stop is that red button that you hit and immediately kills the electrical power to a line. The other example is that pull cord that you see in the bottom right corner. Both examples of E-stops. An overview of machine guarding. So machine guarding alerts workers to potential hazards and provides awareness of the potential injury. So those potential types of injury is electrocution, where you contact with live circuits, entanglement, and injuries such as cuts, bruises, crushing, amputation, or death. And here's a couple of examples of what the signage would look like. The last part of the presentation is the competency assessment. So this would, of course, be expanded in any workplace, but it's an example of what you should be doing at the end of your training presentation to see if the training's been properly understood by the people you're training. And in this case, there's 5 questions that talk about the material we've just reviewed. I would say that anybody that gets less than 90% on a guarding training session would fail and be required to take it over again. But there you have it. I want to thank you for attending today's webinar. And if there's any questions, of course, you can contact Brian Izard, General Manager of CWPCA at our Ottawa office. Thank you.